Hi class. So it's great to see you all here by using the YouTube. Right. So in this YouTube, basically I will focus on the flexible wall, which we also call it as a sheet pile wall, and also to know about what is about the mechanically stabilized earth retaining walls. So after this video, you should able to know how the ship pile wall apply at site, then the concept design of ship pile wall, and also the construction sequence about the MSE wall, retaining wall. Alright, so without further ado, so let's start this videos. So ship pile walls are retaining wall which constructed to retain earth, as we know, okay, water or any other fill material. So as compared to the concrete wall or masonry wall, so ship pile walls are thinner in sections. Ship pile wall can be used to retain the waterfront structure. Okay. Second, as a building diversion dams, such as cover dams, to protect the river bank, and lastly to retain the site of cuts made in earth. The types of material can be used for ship piles such as timbers, reinforced concrete, or even steel, which is the most common material used. Here are some of the examples of the materials of ship piles: timber pile wall sections, the reinforced concrete ship pile wall sections, and also the steel ship pile sections. Okay, so here are some photos which we can see the types of material used by the ship piles. So the first one is using the timber wall sections. The second one is using the precast concrete, and the third one is using the steel ship pile. Okay, why should we use the steel ship pile instead of other materials? Okay, first, it can provide higher resistance to driving stresses. Second, which is an overall lighter in weight, and it can be reused on several projects. It means that after the excavation, then we can withdraw the steel ship pile and use for other projects. It provides a long service life, easy to adapt the piling by just using welding or bolting. And lastly is the joints are less to deform during driving. Okay, the structures of the ship pile wall may consist of these following items. Okay, first, the cantilever type of ship piles, or we add the anchored barricks to the ship piles, or the brace sheeting in cut, the single cell cover dam, the cellular cover dams in circular type, or the circular cover dam in different type. Alright, now let's have a look on the pictures. Okay, so the first picture on the left is the barricks of the ship piles. And the bottom one is the cover dam in the single cell, and the following one is the cover dam in the cellular type, and the last one is the cover dam in the different types. Okay, cantilever wall are usually used as a flat wall or as an earth retaining wall with low wall height, 3 to 5 meter height of the retaining soil. And cantilever wall, they get their support mainly from the foundation soil, so they may be installed in the relatively close proximity to the existing structure. Here are some of the failure mode of cantilever ship pile. Okay, when we look at the first picture, which we call as a fractional failure, whereby the ship bar is still intact but it moving forward to the unsupported side. Okay, for the second one is due to the rotational failure, which is mainly because of the penetration of the ship bar is inadequate. And the last one, the deep-seated failure, is mainly due to the stability of the slope itself. Okay, now we can see the diagram involved in analyzing the ship bow. First, we have the elastic line, and we can draw the pressure diagram accordingly, such as the active side and also the passive side. Okay, so further from there, then we can draw the net of pressure diagram accordingly, and lastly is due to the bending moment. Okay, in order to analyze the ship pi, so there are some concepts that we must understand before we can proceed. So we need to find the equilibrium among the active and also the passive side. Alright, so at first we need to have a point zeros, which we can balance the reaction R, which the submission of the moment from the passive and also the active side will equivalent to 0. After we get the depth of the ship pi wall penetration, then we can further increase it by at least another 20% to 30% to allow extra length to develop the passive pressure R. Okay, here are the steps involved in analyzing the ship bar. So first select a point O. Then we calculate the active and passive of pressure accordingly. If there is any pore water pressure, acids, or the seepage forces, then we should include in the pressure diagram. Then from there we can determine the depth of the node by summing the moment about the 0. Summing moments about the point O. Then increase the D, okay, to become 1.2 or 1.3 based on the node that we calculated. Then we calculate the R by summing the forces horizontally over the depth. It means from the active and the passive side. So whether you can achieve the balance forces from the both side or not, which is the depth will become the H node plus the D that we calculated as mentioned just now. Then we determine the net passive resistance between the D node and D, and then we check the R is greater than the net passive resistance. If not, extend the depth impairment and determine the new R. Right, so finally we can calculate what will be the maximum bending moment, and then we can determine the section modulus of the steel sections based on the maximum moment divided by the allowable stress of the steel sections. Then that will be the step involved in analyzing the cantilever ship pi. So as a rule of thumb, so basically we can also refer to this table to determine the depth of the penetration of this cantilever ship piling. If we have a very loose type of sand or materials, so the depth of the penetration depth of the cantilever ship bar should be 2 times of the height of the retaining wall. Or if this is a loose material, so we can have a 1.5 times of the height of the retained soil. Or if the soil is firm, then we can have 1 times. Or if the soil is considered tense, then we can have 0.7 times the height of the retained soil. Okay, so for the example part, which I will skip it, which we already covered in the class. So I just click through the example part. Alright, so now we will proceed to another part of these videos, which we call as a mechanically stabilized earth retaining wall. MSE wall, or we call it as a mechanically stabilized earth MSE wall. So get their stability from the internal stresses developing at the interface between the soil and the reinforced element. Alright. So the MSE wall are constructed by compacting the soil in layers, which is separated by the reinforcement strip or sheet. Reinforcement strips are attached to the facing unit and extend far enough into the backfill to ensure adequate pull-out resistance. Right. So the type of these MSE walls, such as the reinforced earth wall, the geotextile reinforced earth wall, and the cantilever sheet parts. Okay, here are the example of the MSE wall. Okay, why MSE wall is beneficial to certain projects. Okay, MSE wall have many advantages as compared to the conventional reinforced concrete and gravity retaining walls. So the MSE wall, they use simple and rapid construction procedures and do not require as large of construction equipment. Then they do not require special skill for construction, and they require less site preparation than other alternatives. Then they need less space in front of the structure for construction operation, and they can reduce the right of way acquisitions. They do not need the rigid unyielding foundation support because MSE structure are tolerant to deformations. Of course, cost effective and technically feasible to height in excess of the 100 feet. Okay, here are some of the principal or the major elements of MSE. Okay, such as the barriers, the copings, the mechanically stabilized earth mass, the facing of the MSE wall, then the bench, the pad to support the this MSE wall facing, the foundation soil which can support the earth mass of the MSE, and also the reinforced inclusion which can provide the sufficient pull-out resistance to this facing, the finish grade of the root, the retained backfill. Okay, so this is the original ground surface and the limits of the construction excavations. Okay, the system type of this MSE wall included the reinforcement geometry, so such as linear unidirectionals, which are including straight, smooth or ribbed steel ribs or coated geosynthetic strips. Okay, the reinforcement material, so can be made between the characteristic of metallic and also the non-metallic reinforcement, such as the mild steel, which are usually galvanized to resist the corrosions, the non-metallic reinforcement, which are using the polymeric material such as the polyester or the polyethylene. So the facing system could be many. So some of them, they may using the segmental precast concrete panels. So this is a more common type. So depends on the installer. So they might have their own patented precast concrete panels type, which are using their particular system, wall system. All right. So they can have this dry cast modular block walls unit, so which is smaller, easier for installations of for these retaining wall applications. Right, so they might have this also the welded wire mesh, so the wire grid can be bent up at the front of the wall to form the wall face. Okay, so here we can see some of the example of the facing. So this is the precast concrete panels. So this is another pattern used by maybe the different installer, and this is a modular cast unit, which is smaller as compared to the this panel unit. Here we can see the construction sequence for the MSE wall, which we started to erect the panels pieces by pieces after we have prepared the footing for the panel itself. All right. So once the panel is erected, okay, then we can start compacting the earth behind the panels. Of course, once the compaction layers reach to the particular levels, then we can install the strip accordingly, which we can see at the picture below. So it's either using the wire mesh type or the strip types. Right, then you just repeat the process of construction to the higher level. Right, so then once you have reached to the final level, then you can just install the road surface, the pavement on the top of the retaining wall. So as compared to the others type of retaining wall such as the concrete wall, so the site preparation, the concrete pourings, so will involve a lot of these workmen force, and also the machinery when you doing the concreting for the reinforced concrete wall. While by using this precast panels, or we call it as a MSE wall system, so it can speed up the works and make the construction site less messy, and the works can be finished earlier. Okay, so that's it for my presentation. So, and now we will proceed to the Q&A sections. If there is any question, you can just post it to me and we will try to answer it accordingly. Okay, thank you class for your patience, and also hope you enjoy it. Thank you again.